Hi guys, welcome to Easy Math.
In this video, we are going to see the next lemma. If phi is a homomorphism of G onto G bar with the kernel K, then the set of all inverse images of G bar belongs to G bar, where under pi in G is given by Kx, where x is any particular inverse image of G bar in G. Okay. What is given? If phi is a homomorphism. Phi is a homomorphism of G onto G bar. Be a homomorphism with the kernel K. What is kernel K? Kernel K means set of all x belongs to G such that phi of x is equal to E bar, where E bar is the identity element of G bar. Right? We have to prove that the set of all inverse images of G bar in G bar under pi in G is given by Kx. That means Kx is the set of all inverse image. The other name for inverse image is pre-image. Okay. Kx is the set of all pre-images of G bar in G bar. What's Kx? Kx denotes the right coset. Okay. Kx is the set of all pre-images of G bar. What is the pre-image? Let us see. This is G and this is G bar. Element x. There is a mapping between phi, means the image is phi of x, right? Okay, let us see. This is the mapping G to G bar. If there exists an element x in G, there exists an image in G bar, means it is denoted as pi of x or G bar. Okay. What is meant by pre-image? If G bar has a pre-image or the inverse image, means we denote it as this one. Pre-image means we denote it as this one. Okay. Every element of G bar has at least one pre-image, right? Therefore, you have to prove that Kx is a set of all pre-images of. That means the pre-images are in the form Kx. That means the coset format. Okay. If G bar in G bar, then an element x in G is called the inverse image or the pre-image. Clearly, it is the inverse image, right? And the phi is phi of x is equal to G bar. Suppose x in G is one of the pre-images of G bar, means let us take K from the kernel K. Okay, we have to choose one element K from the kernel K, and if y is equal to Kx. Y is equal to Kx. What is that? K is in the small k is in the kernel K and x is in the element G. Obviously, the kernel K lies in the, that means subset of kernel K is the subset of G. Therefore, small k belongs to G and x belongs to G. Since G is a group, therefore Kx belongs to G. Therefore, this y belongs to G. Therefore, y belongs to G. Okay. Now, can be written as taking phi on both sides. Phi of y is equal to phi of Kx. Since phi is a homomorphism, this Kx, phi of Kx can be written as phi of k into phi of x. Since k belongs to k, that is the kernel k, that element k belongs to k, the value of phi of k is E bar, right? It's the identity element. Already we defined that phi of x is equal to G bar, therefore phi of x is equal to G bar. Identity element into G bar is G bar. Therefore, phi of y is equal to phi of Kx is equal to G bar. K into x. Therefore, this is the right coset. Okay. Hence, Kx contained in the set of all pre-images of G bar. Set of all pre-images of G bar. Now, let us choose one element from G, that is Z. Choose Z from G. Then the images are written as phi of z, right? The image of z is written as phi of z, which is in the form of g bar, which is equal to phi of x, okay? Because that is phi of z is equal to phi of x. Pre-multiplying pi of x the whole inverse on both sides means pi of z into pi of x the whole inverse is equal to pi of x into pi of x the whole inverse. What's the value of pi of x into pi of x the whole inverse? That is e bar. Since these are the images in the group G bar, right? Also, by the previous lemma, that is pi of x the whole inverse can be written as pi of x inverse. Pi is a homomorphism. That pi of z into pi of x inverse can be written as pi of z into x inverse, okay, which is equal to e bar. What's the definition of kernel K? Kernel K is equal to set of all x in G such that phi of x is equal to e bar means e bar is the identity element. Therefore, this zx bar belongs to that kernel K, which implies z belongs to kx. We bring this x inverse to the other side. Hence, what is this? This is the right coset, right? Hence, the set of all pre-images. This is the pre-image of G bar, right? Because z is in the group G. Therefore, now z is in the right coset. Hence, the set of all pre-images contained in the right coset kx. Thus, kx is the set of all pre-images of G bar under phi in G. Okay. Hence the lemma.
Thank you for watching. Don't forget to like, share and subscribe. Bye guys.